Okay, continuing with the independence part. So let me just clarify this a little bit. Let's do here. Are males independent of being a Democrat? That means independence and probability. So what I would do is probability of male, does that equal probability of male given Democrat? So males, that's 80 out of 215. Male given Democrat is 50 over 115. So 0.37, 0.43. Since they are not equal, male and Democrats are dependent. So it looks like, given that you're a male, you have a higher chance of being a Democrat. So if I said, are females independent of Republicans? Well, female, does that equal female given Republican? Well, there's 135 over 215 females. And that's 70 over 100. So females, there's 135 over 215, 0.63. And then you got 70 over 100. That's about 0.7, so no. That would be no. A better way to figure out, so if I said does gender or do, no, are in general gender and party independent, what you can do is just use conditional probability. So you can say, all right, so here are the males. Males only. What's the chance that they're Democrats? So for all the males, 50 out of 80 are Democrats. And then for all the males, 30 out of 80 are Republicans. So 50 out of 80, 30 out of 80, so that's 0.63, give or take, 0.38. So if I said females only, Dems, what percentage of females are Democrats? So, what percentage of females are Democrats? So, of all the females, there's 65 over 135. And for Republicans, there's 70 over 135. So that's about 0.48. 0.52. So, these look to be kind of dependent because it seems as though if you're a male, so if you're a male, you're more likely to be a Democrat. See, you could also look at it this way. If you're a Republican, you are more likely to be what? No. Well, actually, we didn't do it that way. So if you're a female, these are pretty close. But you are more likely to be a Republican if you're a female. So these really should equal up, and they don't. So I would say that these are dependent. All right, so now let's look at a couple of examples. Let's go to this one. It's on page 6. So here's a two-way table. We've got males, voter opinions about building a new high school in town. So 119 males want to build a new high school. 116 don't want to build a high school, and 6 of them didn't return the survey. All right, so if a randomly selected eligible voter is a female, what's the probability she will vote to build a new high school? So basically, this is given that they're female, what's the probability she said yes? Well, 154. Here are my totals. All right, so given that you're a female, yes, 154 to 274. Well, this would be a conditional probability because you're conditioning on the fact that you're a female. Part B, if a randomly selected voter is male, what's the probability he will vote on a new high school? So that's this one. So that's 119 over 241. That's still conditional. What's the probability of finding that a randomly selected voter is a male? Well, there are 241 males out of 515 total people. That's a margin. What's the frequency of a male who did not provide an opinion? 6. Frequency just means how many males did not provide an opinion. The probability that a male did not provide an opinion, probability of them being a male and not providing an opinion, well, that's 6 out of 515. So that's the difference. That's a joint because it's in here. Okay, and then F are males independent, of yes votes. So our probability of males that equal the probability of yes, given that you're male. So male, 241, 515. Probability of yes, given that you're a male. Let's see if these are equal. No, 0.46, 0.49, it's very, very close. It's close. So they're kind of independent. It's not exact. It really should be exact to say that they are, but close enough. All right, let's skip that one. All right, let's go to this one right here, number 1, page 9. It's being a female and participating in sports independent. So it's being a female and participating in sports. So that's 580 over 1,000. And participating in sports is 400, so that's 232 over 400. .58 is equal to 0.58, so yes, they are independent. There's another way to do independent, and that is if the probability of A and B equals the probability of A times the probability of B. So I could say the probability of female and sports, does that equal the probability of female times the probability of sports? So female and sports is 232 over 1,000. Females, there's 580 females out of 1,000 times the probability of sports, 400 over 1,000. So if these two equal, then they are. So 580. .232, and this is .232, so yes, independent. So 2 ways to kind of go about this. All right, let's look at number 3. When a room is randomly selected in a downtown hotel, the probability the room has a king-size bed is 0.62. The probability the room has a view of the town square is 0.43. The probability it's king and has a view is 0.38. Are the events king size bed and has a view independent? So once again, probability of A and B, does that equal the probability of A times the probability of B? So in this case, it would be king and V. Does that equal king times V? Doesn't matter what order you do them in. So does 0.38 equal 0.62 times 0.43? No. So they are not independent. Sorry if you couldn't see that. Number 4, the probability that a person is left-handed is 0.12. The probability they have brown eyes is 0.42, and the probability they have brown eyes and left-handed is 0.0504. Is the event having brown eyes independent of being left-handed? So brown and L, does that equal brown times probability of L? So 0.0504, 0.42 times 0.12. Yes, they are. Yes, they are independent. Okay, a credit card company states that 42% of its customers are classified as long-term cardholders. 35 pay their bills, full in each month. 23% are long-term who also pay their bills. So that would be an and. Female, so that'd be 0.23. So it's 0.42 times 0.35 is going to be 0.147. So no, they are not independent. All right, the results of this poll are shown in the table. For this group of students, the data suggests that gender and preferred music styles are independent of each other. So, okay. One way we could look at this is we could break it up by females. So I almost think like I want to make like a graph, female and male. So techno, what percentage of females like techno? See, I happen to like techno, but only once in a while. Can't always listen to techno. All right, so I'm gonna find all these totals. That's 106, 36, 40, 18, 94, 27 plus 18, 45, that's 65, and 54 plus 36. We have 90, and it looks like there's 200 total. So, of the females, 54 out of 106 like techno. See, 25 out of 106 like rap. I like rap too. I don't mind country, but I'm not going out of my way to listen to country. So that's the breakdown of the female. So what's the probability you like techno given that you're a female? What's the probability you like rap if you're a female? And what's the probability you like country if you're a female? So that was 54 out of 106, which is 0.51. There's going to be some rounding error. 25 out of 106, which is 0.24. And 27 out of 106, which is 0.25. Let's do the same thing for males. See, I'm breaking it up by gender. I mean, I could break it up by techno, but that doesn't make any sense to do that because they want... No, I would never break it up by techno. I'm going to do this. So what percentage of males like techno? What percentage of males like rap? And what percentage of males like country? Now, since Miss Marzak made this worksheet, I think she likes country, so maybe she was biased. So for all these 94 males, 36 out of 94, 40 out of 94, 18 out of 94. So if you were to make a graph, you know, these are all my technos. This is 0.51. Now, there's 24 going above it. So 0.24, and then I have 0.25. So that's country, that's rap. Males, 38 like techno. So that's going to be shorter than that. Here's 0.38, 43 like rap. Actually, 43 would bring it all the way up here probably. And that little bit of 18 like country. So as you can see, the majority of males like rap, majority of females like techno. There's more females that like country than males. There's, you know, less males that like techno over females. So there's a lot of things you can say off this, but these are dependent. These as in gender and music. So they're not completely independent. It appears, and then you would kind of say what I said, it appears more females like techno, more males like rap. But if you were to take a look at something like this, you know, what's the chance you like rap, or rap and male, independent? Well, 65 out of 200 like rap, and given that you're a male, 94, so chance you like rap, 40 and a 94. You know, 0.325. That's not equal to 0.43, so no, these are dependent. So it's all kind of working out. Okay.